is really my great honor to come here to really have a chat with all you guys and to share a little bit of one of my major project outcomes as well. As mentioned by Eric, today I want to talk a bit of my recycled concrete research. I can't hide this one, sorry. That's the best I can do. Okay. Yeah. A little bit further about my research directions. As you can see that my focus is on sustainable construction. I work on green building and also life cycle analysis. As you know, my title today, I want to talk a little bit of the recycled concrete research area. I will not repeat myself about my editor positions and also some of my research funding outcomes and citations in here as well. What I want to share with you is I graduated in here doing my PhD. On the top left, it was my undergraduate photos. It was 2001 that I graduated my undergraduate. I still look the same, isn't it? Yeah, at Hong Kong Polytechnic University. And then I go straight to the PhD at City University of Hong Kong. As you can see, my supervisors, Professor CM Tam is also in the middle and some of my other peers as well. And after that, I spent all my educations in Hong Kong. And after that, I actually got my first job in Australia. I was at on the Gold Coast first, worked as a lecturer in the Griffith University for 4 years before I moved to Sydney. Currently, also staying until now for 16 years at the Western Sydney University. With my over about 20 years, actually under, maybe about 18 years after my PhD, I'm also very honored to receive the title of a distinguished professor at Western Sydney University as well. In the middle, you can see that in 2023, I'm very grateful that I received the fellowship of Australian Academy of Theological Science and Engineering, which is really a surprise and a really great honor for me, particularly with the award, the fellowship award of the ETSI, which is also mainly with the research area that I'm going to present today as well. A little bit more about myself in terms of my research directions. My first degree actually is on construction economics and management at the PolyU, which is, you can also say that as a quantity surveying. Quantity surveying is mostly, if you like to say that, you can also be a cost estimates or different terminologies that you want to mention. But that was my first degree, and that's why my final year project during my undergraduate actually focusing on the environmental management, particularly on the waste management at that time. But again, it is mostly on management component, which is looking into how can we ensure that there's less waste to produce, or when you produce waste, what can you do with it to be more economical or more appropriate to reusing it, but in the management approach. After my undergraduate, I moved to very different from management to become technology, which is my PhD studies, which is doing really the technical side of the recycled concrete, exactly on how we can recycle the concrete waste more effectively. My idea of using it is how to turn waste as resources, because I often see that you have a lot of waste generated. I can manage the waste, I can try to find an approach to effectively reusing it, but the thing is the technical part is still really missing. That's why drawing my interest of doing very technical component of the recycled concrete. Bear in mind that I'm not coming from an engineering background. I don't have much knowledge about concrete. I still remember that when I first studied my PhD, I was looking into a book called What is Concrete? To just really start looking into what is really concrete include or involved, and how's that composed of, and then we start looking into how that technical part be able to work on as well. In the recent years, I'm also working on green building and all the research, because of my management interest, I'm also looking into life cycle assessment, particularly with the recent international interest of climate change and all those stuff. That's why I like to look into the life cycle cost and life cycle carbon emission to ensure that you can reduce cost and reduce carbon in the long term. Talking about some of the data related to C&D waste. This is some of the Australian data, as you can see, which is Australia normally about 75.8 million tons of waste, but with that about 29 million tons are actually C&D waste. But over the last 15 years, we can see that the reuse of that components are quite high. But unfortunately, the way that they can reuse as a high-grade materials is still limited. Normally, it's only about less than 1% of those C&D waste generated. We can be reused as a high-grade materials. We can reuse it, but we didn't utilize it as the best they can. And in terms of waste recycling, I think a lot of you probably know that the best way is to prevent the way that they generate it. But if you want to effectively really has to generate it, probably the best way is to separate doing the waste sorting. So after sorting different kind of waste, you might do the treatment. Even all those prevention, separation, and treatment may be able to do really well in terms of the laboratory environment. And it's still very hard to move it into the market. That is a big difference between the lab to scale, and also a little bit different on the supply and demand in here as well. A little bit information about what innovations in concrete that I personally think like, which is really just some of the information that I'm sharing in here. It might not be including everything, but I want to highlight a little bit of my thought in here. You can see that in the technologies component, there's a lot of, you probably heard of these kind of terminologies, like a lot of 3D printing, a lot of different kind of a self-healing concrete, or different kind of innovations that we have. And talking about this technology side, we also have the smart materials. A lot of us actually looking into nano materials, trying to use different kind of advanced materials to improve the behavior. That is the smart materials. But all in all, I'm not surprising to tell you that sustainability is very important, and particularly talking about not only about waste material, but a lot of us also looking into low carbon concrete and the different kind of utilizations here. I want to highlight a little bit of the terminologies in here. Have anyone heard about low carbon concrete here? Yeah. Low carbon concrete in general is the concrete that you produce with low carbon footprint. But in general, when you talk about low carbon footprint, majority of us actually only doing cement substitutes because of cement productions has the highest carbon emission produced. And that's why when you talk about low carbon concrete, they mainly reducing the cement component by doing the cement substitute materials. However, there's a large components of the materials in concrete compositions are aggregates. In fact, 80% of the, by volume of the concrete, they actually are aggregate components. What if we can actually utilizing those components as well, not only about the cement substitute, not only about the reducing the cement production by substituting the cement, what if we also recycling other components of the concrete, such as recycled aggregate? Recycled aggregate research is not really new. Talking about doing my PhD is already really a high interest area. Even the government at that time, 20 years ago, they also opened a centralized recycling plant in Two Moon. I think currently still operating as well, from what I understand. But it's just changing from public to private operation. But until now, I think it's still very limitedly to use it as the best that they can. That means they are, because of the poor performance of the recycled aggregate. You can imagine concrete waste, they crush it using different kind of crushes, and then they will produce it as a recycled aggregate, depends on what size you want. Mostly is 10 mil and 20 mil. But majority of them still have a lot of old cement mortar attached, which means they're still relatively poorer quality. And that's why, in general, if you have 100% replacement of the recycled aggregate, they will have around 30% strength reduction, which is why we cannot utilize the best that they can. We can only use it for low grade because the strength is reduced. We just cannot find a way to use it in a better way. That's why we can only use it for low grade. That's why, what if we can actually bring not only about the low carbon concrete, which is mainly cement substitute, as I mentioned, but also bringing the recycled aggregate together, which is actually a slogan by the industry when they're trying to promote the product that we have been invented. Because a lot of industry has been having a strong interest of using low carbon concrete. It's a very common term that majority of us know. But the thing is, they didn't really utilize the waste that it can be recycled from the C&D waste for the concrete production. That's why, what if we can actually utilizing both components together? And what if concrete could reduce embodied carbon, lower the embodied carbon in the longer term. Embrace circular solutions. I don't know how much you understand circular solutions, because circular solution is, I mean, you can recycle the products. That means you can recycle it. You generate the waste, you can recycle it. But after you recycle it, can you recycle it again? That is called a circular. That's why I'm very carefully when we are improving the technology in the aggregate or in the material, you will not harmful for them to bring the circularity, that means recyclability in there. And then you can also reduce emissions and also permanently sequester carbon emissions as well. That's why we have invented something called CO2 concrete, which is a new durable and high-strength recycled concrete. What exactly it is? CO2 concrete is a new process of producing the recycled concrete. Very simple process, exactly like what you have done in normal concrete production, but only have a pre-treatment process. That means I inject carbon dioxide into the recycled aggregate first. After that, then I will do the rest exactly the same as what you would do in concrete. This idea has been attracted with international interest, but there's not many actually can really use it as a practical components. We can see that this is a one solution, but can bring endless benefits, including, as I mentioned, the circularity. We can actually turn waste into valuable materials, but you can also capture the carbon and permanently store the carbon emission in the concrete. And the best is I like to do is to add value to the product. Not only about recycle the material to low-grade product, but we can also add value to the product as well. Here, I want to share with you a 90-second video that is produced with the industry partner on highlighting what CO2 concrete producing. I hope the sound will work.
Water. Concrete is the most widely used substance on Earth. Just the time it took to get to this point, 19,000 bathtubs. Traditionally, when a building is demolished, old concrete is never repurposed, making its way to landfill. What if there was a way, not only recycling them, but also using the concrete to capture and store carbon created during the process? Introducing CO2, revolutionary, new, durable, high-strength carbon capture concrete, recycled aggregates, production, low carbon. These treated recycled aggregates are fed into a chamber where they are injected with CO2, which not only improves the quality of the aggregate, but also its performance. CO2 treated aggregates are then taken to a concrete plant to be used in the final concrete. The result is a more sustainable building, reduced carbon. This is a truly circular economic solution that turns construction waste into recycled material without compromise. CO2.
This is just a very simple introduction about what CO2 concrete is. And I share a little bit of what we have in the laboratory. About 8 years ago, we have our first version of the carbonation chamber in the middle of the figures here. You can see it's about 50 centimeters by 50 centimeters by 30 centimeters chamber, which we use it to carbonate about 40 kilograms of material at one time. And since in 2018, my university is interested to pour a CO2 concrete within the university. And that slab is relatively bigger. It's about 3 meters by 3 meters size. And that small chamber will take too long for us for carbonating material at one time. That is why we actually move it as a commercial scale chamber, which is the right-hand side, which is the actual chamber that we have. The left-hand side is just the sketch figures that we have in here. You can see it's 1.6 diameter, 1.2 diameter and 1.6 meter in height, about our human height, which we enough to carbonate at least 1 ton of material at one time, which is relatively easier in terms of doing a commercial scale, which has been done in the laboratory since 2018 in here. You can see the setting is very simple, but it is what we have decided ourselves in here. And a little bit more about a technical size in here. You can see in the top left corner, which is the virgin concrete. If you purely by replacing recycled aggregate with virgin aggregate, the strength actually go down with about 100% replacement. The strength is roughly down by 30%. But if we inject carbon dioxide into the recycled aggregate, the strength will go up, which is very similar as virgin concrete. Not only the strength increased, I also look into the cost as well. Recycled aggregate is roughly about half price of the cost of virgin aggregate. The cost will definitely reduce if we just by purely replacing it. We inject carbon dioxide in, the cost did go up a little bit, but at the end, it's still roughly about 10% cost reduction with 100% CO2 concrete compared to virgin concrete. But bear in mind that we have the similar strength performance in here. This particular research we have done in the laboratory for the last 10 years. And in October 2022, we have managed to done the first commercial concrete slabs at our Blacktown Rehoming Center. In early 2022, this project was attracted with a wholesome accelerator program. The interest of the product, that's why they asked us to join. And we are very fortunate that we have been selected as the Australian winner to join the international competition. And one of the very major achievement of this particular 9-month program is the demonstration slabs outside university. Because I have done a few small projects within the university, but we have never done the outside the university. That's why one of the major target for this particular 9-month program is to done the first commercial slabs, which you can see that this is actually our first commercial slabs product that at the moment is still running in the Pompeii. Anyone go there, you can still see it. You can see that this is the slabs that we have done, which is also partnering with Wholesome with their EcoPad. I'm not sure how much you understand those. EcoPad actually is one of the very major brand by Wholesome, which is a concrete supplier. And EcoPad is mainly targeting on cement, low carbon concrete, which is mainly replacing the cement. That's why if you can hear my presentation earlier, I was talking about the low carbon concrete and recycled aggregate. This is quite an easy marry from their point of view because they have done the low carbon concrete using the EcoPad formula and just changing their original virgin aggregate to recycled aggregate and with similar performance. And they produce the outcome is still very similar of what they want to achieve, but with increasing of environmental perspective. And this particular one, in the international level, I want to highlight that majority of the recycled aggregate, we can only limit to maximum of 30% replacement because of the poor quality, as I mentioned earlier. That's why for this particular first commercial slabs, we want to ensure that we go outside the boundary. That's why this particular slabs, we don't have a 40% replacement. That means it's already outside boundary, which is quite a major challenge by us because we want to go outside the boundary. And then we have a very intense discussion. If you can imagine the 9-month program that we have done with Wholesome Accelerator program, one of the main things is want to do these labs. But the thing is, how can we ensure the products that we have created is actually suitable with the standard requirement? The way one most often question asked by the industry or asked during the meeting is, how can we really follow the standards? I would say, if we are following this, we don't have a recycled concrete standards in Australia, but we just need to follow what virgin concrete need to do. If the product using recycled material with similar performance as virgin concrete, then why we cannot follow this as virgin concrete standard? That's what we have been using it, which is also one of the limitations, to be honest, in Australia, because we don't have any recycled concrete standard at this stage. I'm currently in one of the committee to looking into how can we develop those as well. This is the first slabs that we have done. Although the hosting program was done in 2022, but the partnership is still very strong. All of them is still really interested to looking into how can we really further commercialize the CO2 concrete. And after 1 year, we have managed to pour a second commercial slabs with similar partners under Wholesome and also under AW Edwards as a contractor as well. We done that as the Edmondson Park North Community Car Park in October 2023, exactly 1 month, exactly 1 year after the last commercial slabs. This is what we have done. If you hear me that last slabs we have trying to go outside the boundary from 30% to 40%, and this one actually we go with 50% of the replacement aggregate component, and it's still it is also available in the public. Anyone can also go there to do that as well. With 2 slabs already done in New South Wales, and the third one that we have done, we're still looking into the process is we're still looking into how can we really extend that the percentage and also increase that the conservative consideration by the industry. That's why in 2025 last year March, we actually looking into outside New South Wales. We have actually go with a completely different partners. We were with the partners of mainly Holcim and also AW Edwards. But on the third slabs, we actually moved outside New South Wales, and we moved to Victoria, which is the first Victoria project, which has been poured at Maidstone train maintenance facilities in March. And this one, we actually also go outside 50%, we go actually 60%. You can imagine because of a completely new partners. For the first 2 partners, for the first 2 pours, we are with similar partners. That's why they're quite comfortably to increasing the percentage. But for me, at the beginning, these particular partners, they say that they have never tried more than 50% replacement. But for me, it's no point to do another 50% replacement because I have done that before already. And I was in discussion with them, and we managed to let them to try the products in the laboratory, do some trial in the laboratory, do some few cylinders with 60%. And the contact of my partners is from the contractor perspective, John Holland. They also encourage them to try even 100% to see how you go. It's just in the laboratory. It's just a few cylinders. That wouldn't hurt. Surprisingly, they actually very shocked to see the results of 100% are actually similar as 60%, which is clearly highlighting the benefit of CO2 concrete. And this is also the first time that they have poured for us as well. I think it is a really clear image of providing the confidence to the industry. If you hear me mention in different kind of medias, I often say that the technologies is very comfortable and very confident by me with the team in the university. But the thing is, in the industry perspective, they are still very hesitant because they don't know what that is. If I also can highlight one of the very small story is when we do the first slabs in 2022, you can see that all our crews are actually going there to take videos, to the interviews and all that. And the concrete was a little bit surprised on saying that, what is this concrete? And we were responding to them that it's an innovative concrete. And then the concrete supplier will say, no, I don't want anything innovative. I just want something that I'm comfortable with. But anyway, we still pour at the end. And interestingly, when we're doing the second slabs, the same company, that particular concrete supplier was putting his hands up, want to do it again, which you can see that the confidence level is slowly increased, which takes times. Particularly Australia is a little bit slower than other countries as well. It takes time for them to accept it. But once you give confidence to them, they will also be able to accept this as well, but just take a little bit more time. You can see that these are the 3 slabs that we have done in the commercial scales. In the last one in Melbourne, we actually also managed to collect some cylinders. We're driving 10 hours from Melbourne to Sydney with 55 cylinders in our boot to drive back to just do further testing as well, which is quite a interesting journey for my team to put all the concrete at the back and then we're still driving back. There's a little bit of a roadmap, as you can see, what CO2 concrete want to do. The research was starting in 2015. We have done a few, how can I say, it's like a accelerator program or commercial scales program. First, in 2017, we have actually been selected as one of the top 8 research team in Australia by Innovice, which is targeting on a waste and recycling technology commercialization program. That was the first commercialization program that I have joined. At that time, you can see that the research probably is still relatively early. And another thing is for us in the team is still really new to understand what's commercialization. If I can say that, at that time, I think they are trying to train us as a businessman and businesswoman, trying to understand what business work. they are teaching me all those terminologies that I have never heard of before, which is quite interesting journey. They actually put us weekly, they fly us to Sydney, to Adelaide weekly to just ensure that you have trained to understand the business. If I also can say that they are trying to even brainwash you in a way to understand how business work, because the terminology is just completely different from what you can imagine. But it's an interesting pathway at the start. But I said, because it's relatively early, that's why we continue with our research. And in 2022, as I mentioned, that we have joined the Wholesome Accelerator program as well. And we have selected in May as Australian winner. And we managed to pour the first commercial slabs in October 2022 with 40% replacement. And then 1 year later, we done another slabs with 50%. And 2025, last year, we done a 60% as well. We have actually done a little bit more of the accelerator program in 2025. I didn't update the slides yet. Is we also been joining the third commercialization program under CSIRO, which is like a web research institute. They really help us to further extending the market of how research can go to commercialization. And we are also very fortunate that early this year in January, we have been awarding an accelerator economic program, which is giving us extra support in terms of financially to help us to extend what we have in the laboratory to scale. They are supporting you see my carbonation chamber with 1 ton. I'm actually planning to increase that to 7 tons in the university, and also another 10 tons in the industry partner site as well. That's, you can see that it's really a pathway to help us to further utilizing in the market, and also a bit of upscaling as well. This is one of the major items that I want to mention today is the CO2 concrete. I also want to share a 90 seconds video on how the pathway work as well.
Every second, 10,000 bathtubs can be filled by concrete is never repurposed, making its way to landfill. What if there was a way of not only recycling the concrete, but also using the concrete as a vehicle to capture and store carbon created during the manufacturing process? Introducing CO2 concrete, a revolutionary new, durable, high-strength carbon capture concrete that uses recycled aggregates in conjunction with low-carbon concrete. These treated recycled aggregates are fed into a chamber where they are injected with CO2, which not only improves the quality of the aggregate, but also its performance. The CO2 treated aggregates are then taken to a concrete plant to be used in the final concrete mix. This is a circular economy solution that transforms construction waste into recyclable material without compromising performance. The carbonation process is not publicly available due to confidential agreement. The journey of CO2 concrete has been marked by continuous progress and breakthrough innovation. The first successful pour was completed on October 26, 2022, at the Blacktown Animal Rehoming Centre in Sydney. The 27 by 2 metre slab, using 40% carbonated aggregate. The pour was carried out in partnership with Wholesome, A.W. Edwards, Goody, Sicker, and Mark McDonald. The second was on October 31st, 2023, at Edmondson Park North Commuter Car Park. A 25-metre pathway was poured with 50% carbonated aggregate, with support from Wholesome, A.W. Edwards, Transport for MSW, Liverpool City Council, and Western Sydney University. The third took place on March 12, 2025, at Maidstone Tram Maintenance Facility in Victoria, in collaboration with Heidelberg Materials, Alex Fraser, and the Northwestern Program Alliance. This 25-metre pathway reached a 60% replacement rate, our highest yet. Each pour builds momentum, pushing CO2 concrete closer to mainstream adoption. Looking ahead, we will continue to promote this product, working closely with government to ensure that the implementation of innovative solutions strengthens industry demand. With collective effort, we believe every step we take brings us closer to building a better and cleaner Australia.
This is just a bit of a journey about my CO2 concrete. I want to highlight that as a researchers, we've done a lot of research in the laboratory. We may be trying to commercialization, but the thing is, how can we really move it out of the lab and also use it to utilizing it? And that is one thing. That is the technology side we've done well. But the thing is, how can we really market it? If I can highlight three main things that with different accelerator program that I have joined, one of the main thing is we are looking into business plan. That means how business work. That means we understand that not only about technology component, but also understanding how the industry looking into the product work as well. We develop different kind of models to ensure that they're cost effective, to ensure that they're industry interest. That's the one thing. And the second, we were doing the demonstration labs to trying to move it outside to the lab, which really need industry support on that. But the third one is also very much interested for me recently is about commercialization plan. I don't know any one of you understand what's commercialization plan. Communication plan is you probably know about LinkedIn, you know different kind of social media, but they actually encourage us to do more of those because they can see that it is important for us to move our research outside of the university or outside of your comfort zone, if I can say that. That means they are encouraging me to actually putting a lot of different kind of videos. All these video actually supported, financially supported by the industry partner. They encourage you to do all those stuff. And also they recreate my logo because they also put a person to train with me to say that different kind of logo has actually different kind of perspective. This is actually the second time that we change the logo because they can see that the logo may not be able to ensure how is that related to the product. That's why they want to change the logo to have the feeling that is exactly what we want to deliver. If I can also share with you that their communication is quite different from what we can imagine. I still remember that because of we are joining an international competition, we had to do banners, banners. And obviously doing the banners, if as an academic, we might put a lot of information there to ensure that you can get all of those. But at that time, they're actually suggesting only one sentence. And to be honest, that's not even a sentence because it's just a few words there, not even a complete sentence from our perspective because there's no verb, no nouns and all that. It's not even a sentence. But they like to put a dot at the end, a full stop at the end as well. But this is how the communication of their perspective is looking at. That's why the whole communication plan is very different from what we would imagine. There are the three things that we have been really targeting on. And that's why not only about laboratory that we are working, but also looking into the different component to extend it to the market. This is one of the major things that I want to highlight for today. But if you don't mind, you can also see that majority of the informations that are publicly available, you can also look into this webpage, co2concrete.com.au. I didn't really share a lot of interview videos because each of the poll, we also done an interview as well. All of the interview videos are available under the demonstration slabs. You can also see those information again if you're interested. And this is just a bit of a story from what my interest in passion to innovation. I want to also highlight one of my recent projects. 5 minutes. I know that I'm running out of time, but I just want to highlight a little bit of another recent project, which is just commenced last October, which is the ARC Industrial Transformation Training Center. The title is called Digital Platform for Net Zero Ecosystem Lifecycle. You can see that what we are trying to do, or short term is called Nobel. What we are really trying to do is to ensure that we have achieving in net zero. But you can see that we have different kind of partner university. Majority of them are university, but we also have a partner in UK as well. We also have a lot of industry partner support on the right-hand side that you can see. What is this exactly try to achieve in Nobel? We actually try to looking into different components. Mainly is trying to looking at how can we ensure our project-based digital platform be able to move it to the product and also move it to a whole system, because a lot of us may be looking into a small component like a material, like what I mentioned today, the concrete. But the thing is, how can we really move it to a systematic approach on looking into net zero? And that is what we are aiming to do. And this particular training center, we have 5 major programs. The first one is industrialization, or similar terms that you probably heard about is prefabrication or modular constructions. This is the industrialization component. Resilience, a lot of us probably heard about flooding or earthquake, that kind of how can we ensure the resilience component are able to achieve by different kind of research. Decarbonization, which is the most common one, also the biggest program in this particular center, because we want to ensure that the materials, the product that we produce is low carbon. And also using different kind of assessment, like life cycle assessment or cost benefit analysis, to ensure that they are low carbon as well. Digitalization, since this particular training center is about developing a digital platform, that's why the digitalization is really important, but you cannot do it without the fifth program, which is the integration. This particular industrial transformation training center, we are planning to train around 25 to 50 PhD students, at least 5 postdoctorate researchers. And I mentioned about the collaboration. We have national and international university, but also have 13 national industry partners supported. In terms of funding, we have 5 million Australian dollars receiving from Australian Research Council, but we also have supported by a university and also partner as well. Total of roughly about 16.8 million of funding for the 5 years. And this is just about the structures of the training center. We are still currently waiting for the first committee to be discussed, but we can see that I'm the proposal center director, and I have 2 deputy directors looking into the industry and also the training component. We also have a very fantastic center manager to support us doing all the professional work. And with 5 programs, we have also the program leaders. If you can see that we are trying to have at least 2 members. One is relatively senior researchers to support the program, but we also try to use that to train a little bit less senior professors in terms of as a program leader. That's why we always have 2 program leaders to support that as well. At the end, I actually, recently we have created a 2-minute video just to promote about how this training center work. Achieving these require a shift from traditional construction to digital platform-based methods. The AIP Industry Transformation Training Center for Digital Platforms for Net Zero Building Ecosystem Lifecycle is shaping the future of this transition. Our team is developing 5 coordinating training programs that bring together digital innovations and sustainable technologies. Through that, we aim to equip a new generation of building leaders who can turn research into real net zero projects. We focus on modular and prefabricated product components. By automating production and on-site assembly, production can progress much faster with higher quality and delivery less weight. We are designing building systems that can evolve with future needs. By using material particles and smart sensors, components can be reused or swapped out, improving safety and resilience throughout the building life cycle. The goal is to embed life cycle assessment and carbon reduction strategies from the outset, from design process to construction policy. Every decision is guided by these carbon footprints to achieve generate emissions reduction. Our work applies AI, digital tools, and blockchain to link every step of the supply chain. This provides companies with real-time information and predictive tools to make better, faster decisions across entire projects. What we are doing here is bringing people, quality, and procurement frameworks together. By integrating these elements, individual innovations work seamlessly as one system to deliver true net zero outcomes. For these 5 programs, Nobel is equipping Australia's construction workforce to make net zero buildings the norm, not the exception. That's just a very quick highlight about how Nobel work. And thank you very much.